Hello, we're Team 117 for CS62310, and this is our star search simulation system demo. My name is Bharath. I'm a software engineer at Amazon located in Sunnyvale, California. I'm joined by Rahal and Malith. Rahal is a software engineer at Achievers in Toronto, and Malith is a software engineer at Northern LifeLock in Toronto. For our star search simulation system, we've come up with two proposals, a graphical user interface and data persistence. Our graphical user interface provides users with a visual representation of the space grid, which provides real-time updates as drones move throughout the space region. We also provide buttons to allow users to interact with the simulation and also provide a real-time status panel showing the status of the simulation. For data persistence, we allow users to save the state of a simulation at an arbitrary point midway during a simulation, and we allow them to restore that simulation state at a later run. Now I'm going to go over how to build and run the star search simulation system. So this is a package over here. We have a run.sh bash script that we can run that will build and run the star search simulation system. So I'm going to do that right now. So while it's being built, it generates a sources.txt file and then generates a build folder that has all the artifacts. So now I'm going to load up a scenario file. So we're presented with a dialog box where we can select our file from the file system. I'm going to select scenario 9. Now my colleague Malith will explain more about the graphical user interface.
Thank you, Bharath. Now I'll be walking you through our graphical user interface. Our graphical user interface consists of 5 different panels. On the top center, we have our control panel. The control panel has 3 buttons. The new button will help you load a scenario by choosing a scenario config file. The save button will help you save the current state of the simulation into the disk. Finally, the load button will help you load a such saved scenario and continue on your simulation. On the left-hand side, we have our status panel. It has information about the total size of the space region, the total number of explored versus explorable cells in our space region, the number of turns used versus number of maximum turns available in this scenario, and finally, the next drone to make a move. The next panel is the grid panel in the center. The grid panel contains all the information about space region cells and their content. For example, the stars, the suns, the drones, the empty spaces, and even the drone IDs marked right on top of the drones. They also show the X and Y indices for each of the space region cell. The grid panel also can scale depending on the scenario size. Let me show you what will happen when we load a scenario which has many more space region cells. As you can see, it has scaled down the images and to accommodate the full view. Now let me go back to our original scenario. At the bottom, we have our navigation panel. The navigation panel has 3 buttons. The next button will make one drone movement in the simulation. The stop button will complete the simulation at the current state and print a report. And finally, the fast forward button, which will take a simulation to its conclusion. To show that, let me open a new scenario. Let me make a couple of moves manually and then hit the fast forward button. As you can notice, we can see on the status panel the values are being updated as the drones make their movements. Okay, the simulation has ended. The final panel is the logging panel. As we have already seen in action, it logs every drone movement as they make them. We can also see this information in our terminal. Now my colleague Rahal will explain how to save the current simulation status to a file and load it. Thank you.
Thank you, Malith. Now I'm going to explain how we can persist the state of the Star Search simulation. To do this, I already opened a new scenario file. I'm going to step through this scenario a few times by clicking the next button over here a few times. You can see as I click next, our drones are moving as expected. Notice our state over here, it says turns 6 out of 100 turns. And next drone is 1, which means when I click next, my drone 1 over here will move. Now let's say I want to save this state and work on a different simulation and come back to this state later. To do this, I'll save this state by clicking Save button over here. It's going to ask me where I want to save my file. So right now I'm in my home directory. So I will give the name as save1 to my save file. I will click Save. It will save my current state in my home directory as save1. Now to start a different scenario, I will click New over here. I will navigate to a different scenario file. This time I will select scenario 11. I'll open. Now you can see I opened a different scenario file. Again, I will click next few times in this scenario. Once I'm done with this scenario, what I can do to load the previous file, I'll click Load over here. Then I will navigate to my home directory, select the save file from my previous scenario. I will click Open to open that state. Now you can see it loaded the previous scenario, which says turns 6 out of 100, and my next drone is drone 1, and all the state was loaded from the previous scenario. Now I can do next, and it will start functioning as we expect. My drone 1 just moved. I can click next again. Or I can hit fast forward. And also to stop the simulation, I can just hit stop over here. So as you can see, our save and load functions are working as expected. This concludes our demo for this presentation. Thank you.